Hello everyone, welcome to my channel Physics through Computation. First of all, wish you a happy new year, belated happy new year, and sorry for being so late to update my new video. So today's topic is basically on how to visualize the coordinates of the molecular dynamics simulation, the talk that I have already given. So from there you have seen that I have generated the XYZ coordinate of the particles, and then I haven't shown you the code to visualize the particle positions and then how to animate them. In a nutshell, what I'll tell in this video is the following. So you have the XYZ coordinate, how to visualize them and how to animate them, like the melting scenario, like the usual random configuration or everything else. You can see from this thing. From this video you will learn how to visualize everything. So now let's start. In my earlier video I have given a talk on how to generate a random initial configuration in for molecular dynamics. So I am using the same code here, so I am not describing this part because this is already given in my earlier video. So please go through it, and I'll be giving I have given the link in the description box. So if you haven't gone through the earlier video, please go through it and then I come to this video and watch. So this is basically the usual part, and then basically what is the main part is the following. So this is your usual molecular dynamics code, let's say, or it's a usual thing, usual any code. So here basically what I did is basically I generate some random number for the first position. So let's say I have total 864 particles, and I have rho equal to 0. Rho is the density, which is n by this LQ, number of particle divided by the volume of the box. But here the volume of the box is not given, L is not given, so rho is given. So we'll calculate the LQ from this thing, and then will calculate as you can see we have calculated Lx, Ly, Lz, which is number of particles divided by rho to the power 1/3. So likewise that. So now I'll generate the position of the 864 particles randomly. So first of all what I did, so I first basically generate a random number r, and then I basically initialize the first particle position randomly, and then I put a loop which is going from 2 to the other n particle, and then basically I generate the random position. And here in this thing, in the second loop, where I start a loop from j going from 1 to I minus 1, here what I am doing is basically I am checking whether they are overlapping or not. If they are overlapping, then basically I am basically ignoring that configuration, ignoring that position, and then I am regenerating it. So I am asking it to go to the 11th line. So that is how it is going. This is how the particle random position is being generated. So that's why I basically firstly generate one first position, and then from second position onwards to the total number of particles I generate, and I check with the earlier particle that are already being placed in the cube. So then basically I check whether they are being overlapping with this other particle position or not. If they are overlapping, then regenerate that position again, such that it doesn't overlap. So this is how the code works. So then basically you can see I have calculated the distance from the ith particle to jth particle, and then I apply the periodic boundary condition here, and then basically I calculate dr, and then if sigma is basically the distance, if sigma is the basically cutoff distance, so overlapping distance you can say. If this is less than equal to sigma, then basically it means basically it is overlapping. There are not much enough distance between the two particle position that is generated, and then basically we again regenerate that position. So it will go and go again until it basically go up to the total number of particles. So now what next I will do, basically after this loop, so this is the loop, this is this ith loop, this I loop. So this ends here. So once it exits this loop, it basically have all the particle position which is being generated randomly, x, y, z position. So next, what is the task? The task is to visualize the particle position. So now, so there is a way to, there are many softwares to visualize actually. So here in this video I will be talking about only 3 softwares, which is JMOL, Ovito and VMD. So you can use them freely, but Ovito has a paid version as well, but we'll be showing the free version only. And also you can use JMOL as well as VMD. And I will also show how to install them, and in briefly I will show the how to install them in Linux as well as in Windows, and then I will be talking about how to write the position, and then the particle position, and then basically the how to visualize them. So this part I will describe later, and now let me talk you how to install these softwares JMOL, VMD and Ovito. So for that I will be needing help. So I have already written some link, so let me show you. So for Ovito, you just I will be sharing the link in the description box, so you can just have a access on that. So let me open a tab, Google Chrome, and then just paste and go. So here this is the basically link for downloading Ovito. So as you can see, you have Ovito Basic and Ovito Pro. So just download the Ovito Basic, and this is for since my system is Linux, so this is basically showing me the Linux version, but you can also click on the Windows version, and you can download the exe file, and then click on the executable, and then you can install. So this is how you can install in Windows, but in Linux it's very easy. So and Windows also, if you just install this exe file, it will be, you know how to install a exe file, because you can just double click it, and it will ask you some question to whether to install yes or yes no type, and then you can just allow it, and then it will be installed. But in Linux you have to install the star file. You have to download the star file, and after that you have to enter it, and then once you enter, you will get something like this file. So let me show you. So something like this file you can see. So softwares, and then there you can see here. So here you can see several files. Once you enter, you will get some file like this, and then if you once you open it, you will see three files, and then if you go to the bin file, and then you can see there is a icon which is Ovito, and then now here if you open a terminal after entering it, so then you can open the terminal, and then you can just type Ovito, and then the Ovito will be opened. Yeah, so this is how the Ovito will work. So whenever you want to put it in whenever you want to run it regularly, like in other from other folder, you just copy this location, and then put it like, let's say I run it from my home. So in my home this location is not there, so what you will do is so this is my home location. If you see pwd, if I do, it's this home location, but if you just type this and then Ovito, then basically it will come. So Ovito will open. So you have to remember this location. You have to copy this location, and then once you have the location, and then you can run from any of the terminal. So this is for the running the Ovito, and this is the Ovito installation process. Okay, so let me just copy the link, and then I will show you. So installation of JMOL is very easy. So you just need to copy it and then paste it. So I will be sharing the link in the description box. You can just download it. So you can either download from SourceForge.net, whether you can download for Windows or Linux or whatever is your operating system is, and you can see that it download, or my download will be starting like this. Yes, so it will be downloading. So I will just cancel it, but if you just download it and then run the executable, then it will be running. So that's it here for JMOL. But in Linux, what you need to do is the following. So if you just write sudo apt-get update, and so then let me show you. So let's open a terminal here, and so paste it here, and then I have to give my password. It will not show your password, but it will be updating. And then in my system JMOL is already installed, so it will not show it will show that it is already installed, and but in your system it will be installed if you just type it and with your password. So okay, so it is completed. And now if you just type this sudo apt JMOL, you can see in my system it is already installed. So JMOL is already the newest version, and that's why it is not installed yet, but in your system it will be installed if you type. So this is how you can install JMOL. But for now, next is for VMD. So for VMD is you can you can basically copy this link and then open a browser and then search it. And here, from here in this link you can download VMD. But for downloading VMD you need to fill up is little details of your institution, of your name, and then you can download. But it's free, all is free, but you just need to put the details such that they want to keep track of how many downloads are there or other stuff. So that's why you need to give some details about that, and then basically you can install VMD in your machine. So so this is basically how you can install VMD. Let's open. Let's It will take some time to open. Let me show you the next link maybe. Okay, so let me check. Yeah. So it will come eventually. It will take some time and then eventually it will come. Okay, and here you can also have some, I think, the tutorial for how to install VMD. Yeah, so you can see you just need to register with your username, with some of your username and password, and then you can put your some username. If you you can continue your download. So once you give some username and password, you can continue with download, and then you will be logged in, and that's how we can install VMD in your machine. And then the full procedure of VMD installation is given in this PDF, I think. So here you can see there are in the there is the option for downloading VMD for different operating system, Linux, Mac OS and Windows, and you can download any of the version. And yeah, here you can basically this PDF you can go through this PDF, and here it is line by line it is written how to install VMD. So this is how we can install three of the software, which is VMD and then JMOL and then basically Ovito. So all of them are available in Linux as well as in Windows. So that's why it is very easy to keep track, and then it's very easy to learn how to visualize the atoms. So let me go back again to the code, and but before going into that, to visualize the atoms you need to save the file in XYZ format. So what is the XYZ format? So let me open the Wikipedia link. You can see, so this is a sample XYZ format. So in the .xyz format means the extension will be XYZ, so it will be .xyz. Like for text file it is .txt, for dat file it is .dat, for you have seen that for PowerPoint it is .ppt, and you can see for PDF it is .pdf. So that is called the extension. So here the extension is .xyz, and this is the extension. The sample file will be a sample file name will be file.xyz or new file.xyz, something like that. And now here you can put the number of atoms, how many atoms you have, and then this is the command line. You can write whatever properties you want to write here, and this is basically the JMOL or any software will take it as a comment, and then you can put this element and then XYZ values of the particle position. Element can be your ID or particle type, like whether it is oxygen atom, whether it is nitrogen atom or something like that, that you can put, and then this will be XYZ position, and then you can write. So this is how basically a XYZ file format will look like. So here you also given a sample file format. Here you can see there are 11 atoms, and this gap is there. You can see for they haven't written any comment, but this gap you should have given. So this gap should be there, unless if you don't want to write a comment, that is okay, but this gap should be there. And then basically this is basically the this element, whether it is carbon, nitrogen, hydrogen or something like that, and then basically their position, XYZ position. And this is basically for similarly for animation also, you have to basically follow the same notation. You can see this is the first set of thing, the number of atoms, command line, and then the atom type, and then their position. Similarly for the second, this is the first snapshot. In the second snapshot also you have to do the same thing, and similarly as well as in the last snapshot. So you have to repeat the same thing in the loop manner, in the sequential manner, for the animation. To save it in animation, you can see they have also written that most molecule viewers such as JMOL and VMD can show such animation from XYZ file, and that XYZ format M successive, that the following is an example of XYZ format for M successive snapshot, which can be rendered as an animation. So this is how you can save. So let me now go to my code such that I can show you how to save the, how to visualize it in three of the software, which is JMOL, VMD and Ovito. And so I have described up to this part of the code, and if you don't understand this part, I have already made a separate video for how to generate a random initial configuration. You can, I have given the link in the description box, please go through it, and then you will understand how to generate a random initial configuration. So this video is entirely focusing on how to visualize the atoms through different software like VMD, Ovito and JMOL. So up to this point, after this loop, you have all the 864. We have the 864 atoms. So after this loop, you have position of all the 864 particles. So now the last thing remaining is basically how to write it in XYZ file. I have already described the format for the XYZ file, so we will be following exactly same notation. So for JMOL, so this is for JMOL. First let's look at this part. So yeah, so this is for JMOL. So you can see I have opened a file whose file name is random underscore pause underscore jml dot xyz, and then basically, so let me first switch off the Ovito part, so then I will describe Ovito. And so okay, so in JMOL you can see I have opened a file. You can also write something like action, which is write, and this is all. And then basically we have to write the number of particles, how many particles are there in part. And this is basically the second line, as I have described. This will be a comment line, you can write anything. I have written random position, but you can write whatever of your choice. And then the important part, which is a loop goes from 1 to n particle, and write in the same file the element which is the type of the atom. I have written oxygen, you can write also H, you can write also N, any type of atoms. And then basically X, there xi, yi, zi means the position of the ith particle, the x, y and zth position of the ith particle, that you have to write here. And then they have to close the loop, and at the end you have to give a gap, that is a rule, you can say. So this gap and this gap for the comment, if anywhere, even if you don't write any comment, you have to give this gap. So these two gaps are important. So then now what I have to do, just save it and then let's run it. Okay, so let me also save this. So now I have saved it, so let me run it first. So this is config.f90. so g fortran config.f90. now the executable has created /error out, and then run it. Okay, so let me show you. Yeah, so random pause jml.xyz created. So now it is ready to visualize in this xyz file is ready, and now it is ready to visualize in JMOL as well as in VMD. So let's open with JMOL first. So for JMOL, if you are in Linux user, if you install with sudo apt-get that I have shown, then you can just write JMOL and then random pause dot jmol or xyz, and then basically it will show. So you can see it is a nice molecular structure, as you have seen in the chemistry notebook, in your chemistry book, usual chemistry books, and this is how it goes. And the bonds and the bonds they have put depending on the atom type that you have written, but you can always remove the bonds, that I will show you. So yeah, so then basically let's zoom out a bit. So let's make it 50%. This is, I think, well enough. And let's remove the bomb. So what I did, I just right click it and then zoom, and then I do it 50%. You can also could zoom out and zoom in, and then I go to the display, then bond, and then just select none, such that the bond has been disappeared. Now you can also display the bounding box, Yeah, you can see this bounding box, nice bounding box has been created. So you can just scroll it and you can just rotate it whatever of your choice, and you can also change the color of the atom. So you can just right click and then color, then atom, then you can just select red maybe. Yeah, so you can just change the color according to your choice. And now you can also save the snapshot like file, and then you can also export it image, and let's save it. Let me save it random. Yeah, it automatically renames actually. So save. Then I have saved. You can, if you see here, it will be saved. Yeah, so this snapshot has been saved. So this is how basically you can plot and see in JMOL. So this is very easy, right? So this is very easy, and you can do anything. You can change the color, you can increase the bond length, you can increase the atom size. If you want, you can display atom maybe 25%. Yeah, so you can do whatever of your choice. But you can see, since it is a non-overlapping random configuration, none of the atoms are overlapping with each other. So this is how JMOL works. So this is for JMOL. Now we can exit. So now let's do it in VMD. Same thing in VMD. So for that, what you have to do, so you have to just write VMD here instead of JMOL. So yeah, so now VMD will be opened, and here you can see they will open two of the windows. So this is the VMD main window and this is the display window. So right now you can see there are no molecules, and there are just some lines drawn here because it's by default VMD plots like this. And then basically what you have to do, you have to go to display, and then you have to okay, so you have to go to graphics and then representation, and there another pop-up window, another window will pop up, and then you can do the drawing method to be CPK. So now the bonds are there, but you can actually reduce the bond size to 0 such that the bond disappears. So now you can see all the atoms like they are there in the JMOL, and you can just rotate and play with this. You can just rotate it and then it will rotate according to like that. You can see that this is they have automatically detected that we have 864 atoms and we have only one frame, right? So we have saved only one frame, that's why it is showing one. So now you want to see the box around it, but to see the box around it in VMD you have to do a little uh, different thing. So you have to set, so you have to in the terminal, if you see in the terminal now a VMD is there. So instead of your dollar sign, usually this dollar sign, this VMD now comes, and here you have to write this thing PVC set. this is this is the LX value, this is the LY value, and this is the LZ value of the box, and for all the particles. So then enter, and then next command is basically PVC box. So if you write PVC box, then the box will appear, PVC box. So if you see, yeah, so now the box has appeared, right? You can decrease the box size, you can increase the box size by scrolling it, and this is how it basically comes. And here also you can do several things, like you can also change the background, which is this, or you can also maybe solid color is fine. And you can also do accesses of lower right. You can also decide whether to put this axis maybe top. So okay, so then also you can do several things in graphics, representation, coloring method, maybe gray, something like orange. You can do whatever of your choice, so that's not a issue. So this is how basically VMD works. So this is in VMD. You are, if you want to visualize, this is how it will work. So next, so just quit it. Yes, maybe. Okay, so it has quit. So now let's come to the Ovito part. So just clear the window first, and let's try the same command with Ovito, and let's see. Yeah, so you can see, so it has also already detected, and you can see it has detected column 1 has already particle type, and column 2 has position, column 3 has position, column 4 has position, which is x position, y position, and z position. So it has already written that. Now let's okay. Yeah, so it is showing an error, right? So invalid number of particles in line line 867 of XYZ file. What is the reason? So the reason is that the XYZ, if you see here in the code, so you don't need this extra gap for the Ovito format, but for JMOL and VMD you need this extra gap, but for Ovito you don't need. So now let's switch off this and then switch on the other part such that the error doesn't occur. So let's switch off this and comment code, and now let's see whether this error comes or not. So let me first cut it. So you can see this error, invalid number of particles, because the extra space is basically occurring the error. So let's see it, because if you see in this comment everything else is fine, so you can also write n here, so that's not a problem, but everything else is fine, only I am not putting this extra last line gap in the in for this part. So let me run it. So I have already run it. So ls minus lrt, and you can see this has been created. And now if I just put it Ovito random pods ovito.xyz, this error will not come. So it has already detected, and then okay. So you can see this error is not coming because because of the last space, but it is important for other two softwares, JMOL and VMD. So you can see here, you can visualize this thing in four different windows and 4 OS. And this is basically, so if you let me cut it, and then if you open it again, so you can see this is the XY plane, this is the YZ plane view, and this is the ZX plane view, and this is the three-dimensional view. And here also you can do several things. You can color the particle. For that you have to add this add modification, then coloring assign color. You can change the color accordingly. Maybe this color will look like atomic, so this is basically the color. So you can do whatever thing you want, and you can also save it here as usual. So you can also export file, and whether you want to save it in different format, PTK format, XYZ file, PDF format, or something like that. But if you want to save the snapshot, and you have to take this and then you have to save it. You have to put this camera, you click on this camera and then save it. So this is basically Ovito, let's say. So save it, and then basically if you cut it, and then it will you can see here the Ovito snapshot has been created, but it is cropped because I think the view has been zoomed. So if you save it now, any of the windows, if you want to save like this window, just click on this and then this will be saved. So let me save it. So Ovito.png, let me replace the earlier images. Yes. So then, and then basically if you open, yeah, you can see this is how the Ovito snapshot will look like, and this is the JMOL. And VMD I haven't saved. VMD also you can save. So so this is basically, this is how Ovito works. So this is for single snapshot for all of the three softwares, JMOL, VMD and Ovito. But now if you want to create an animation, then how will you do that? So then basically what we have to do is basically we have to save the same XYZ file several times in the same sequential manner. So this is the same code, but what I have done, I have generated the random configuration several times. So every time you generate the configuration, all the configuration of all the 864 particles, every time you generate, you get a new configuration. So I saved all the random configuration, and then I put it in a file, and then that can be work for me as a animation, right? Because every time you generate, you get a random configuration, and it will look like some gas molecules are moving, because for gas molecules the molecules are moving randomly. So if you save the random snapshot every time, then basically you will see, if you watch the snapshot continuously, you will see that it is basically a movement of a gas molecules. So what I did basically, for the same code, this part is same, so I just put a extra do loop here, such that I basically keep track of how many random snapshot I need. So for here I am taken 10, maybe I can do it 20. So I have 20 random snapshot, and I write it in the same format, same file. This is the JMOL format, this is the Ovito format without the extra space, and here with the extra space. So I save it this sequentially, this 20 snapshot. This is the time step. So in your MD loop, what will happen? This will be in your MD code. This will be your MD loop, and you will be you want to save the snapshot at each time step. So then basically you have to put this thing just before ending of this MD loop. So whenever you're doing MD, so this will be your MD loop. So your MD loop, then basically you do force calculation. First you will do initialization, then you will do momentum initialization, then you will evolve the system, and then we calculate the force, and then basically just after the increasing the time step, like t to t plus dt, some that thing, just before doing that, just put this part, or maybe if you want to visualize in Ovito, then this part, or if you want to visualize in JMOL or VMD, then put this part in just before ending the main molecular dynamics do loop, and then you can just save the you will be this code, this part will be saving the snapshot for each of the time step. And then it will basically then you have several snapshot, and you have several data for the several time step, the several you have the data for the configuration for several time step, and then you can basically do the animation. So this is basically the thing. So this is how the same thing I have written. The only change is that I am doing the thing for 20 times, such that I can get some 20 random snapshots. So this is the same thing for Ovito, and this is the same thing for JMOL. And now let's run the code. Okay, so let's clear the window. Okay, so G4turn maybe a compilation flag -03 config all dot f90 dot slash a dot out. So it has been generated. You can see for Ovito it is generated, for JMOL it is generated, for JMOL and VMD it is same. So I am just generating for only only for JMOL. So let's first visualize with JMOL. Random pause JMOL all dot xyz, and now it will be animating. So first of all, I basically do the full screen, and then right click, then zoom, then 50%. Then I basically display bond none because I don't need bond. Then I check the bounding box, and then I just slightly shift it, and then go to tools, and then animate, and then once. You can see how the animation goes. Just to go to tools, if you do it in loop, then it will be animating in a loop. It will first start and then stop, and then again start and then again stop. It will go. This is how basically, this is basically random gas molecules are moving. This looks like something like that. You can also save the export the animation like the same way, like this. Okay, so this is how basically it works. You can take it at particular snapshot, you can take at particular time, then everything you want to do, you can do it here. So this is how it works. This is how it works in JMOL. So now do the same thing in VMD. Let's clear the window and do the same thing in VMD. So VMD, then you have to write VMD, and just open it, and you can initially, as you know that by default it will plot by line, and then you have to go to graphics, then representation, and another window will open, and then drawing method cpk, and then basically what you have to do. Okay, so then you have to put the bounding box. For that you have to put this to command. Okay, so these two command, because my box size remain constant. So lx ly, for lx ly lz pvc, and then basically I have to do it pvc box, and then this box will appear, right? And now let's little bit zoom out. Then basically, if you then you don't want the bond, right? So graphics representation, then you just need to make the bond radius to be 0, such that they will not show any bond. And then what you have to do, you have to, okay, so you have to click on this, and then it will animate, I think. Okay, oh, I think I have opened a different file, maybe that's why it is not showing. Oh, why it is showing only one frame? Let me just check once. Okay, so this is this, and then display graphics tools. Okay, loop back once. Okay, okay, so let me cut it and then again restart it. So maybe the Ovito all will work. Okay, yeah, so I think the space is needed, otherwise it will not be considered in VMD as well. So you can see now it is showing 20 frames, but I have to switch off, I have to change the representation method, otherwise it will look a nightmare. So sorry. Draw style CPK and bond radius none, and also I have to set the PVC box condition, which is this. Let me copy it and then paste it here, and then PVC box, and let me check it now. Yeah, so this is how it looks, and now it will be animated because I have already, you can see the 20 frames are there. So the for VMD, for animation, this space is necessary. So now if you just click on this, it will, yeah, so you can decrease the speed a bit. This is right now because this is very high speed, so you can decrease the speed and then visualize in any of the planes. So this is how in animation in VMD works. This is how you can animate in VMD. You can zoom it, you can do like this, and everything you can do. Okay, so this is how it works. So you can increase the speed from here, you can increase the step from 2 step, it will show every 2 step. You can do it loop, because in loop it will animate continuously. If you do it once, it will do it only once, the animation it will do only once. So it will go, now it is loop, so it is going and again coming and going. But if you do it once, then it will go and then stop. So as you can see here, yeah, so this is how it works. You can control the speed from here. So this is how animation is done in VMD. But so the point is basically it will this space in the last line, it is necessary. So for for not this one. So for VMD also, for and to if you want to animate, then the last line space is not necessary for VMD. But for JMOL it is necessary, because otherwise it will not basically recognize the animation frames. So you have 20 frames, it will not recognize. If you don't give this space, it will not recognize in JMOL. But this space is not needed in VMD as well as in Ovito. So this is basically the thing. So the point that I want to mention is basically to animate, to save the data. If you want to animate in VMD or in Ovito, you don't need the last gap. But for JMOL you need the last gap, because otherwise JMOL will not recognize that individual frames. So you have 20 frames, it will not recognize, it will consider it as a one frame maybe. So this is how it is done in VMD. So now let's do it in Ovito. So now let's do it in Ovito. So Ovito, random pause, Ovito, maybe all. Yeah, so it will first ask for particle type and then this thing. Yes, I confirm. And you can see here also it is showing from 0 to 19, because I have total 19 frame. You can also scroll, and from here also you can see this is basically how it is moving. But if you type this, it will automatically do it for you. Yeah, yeah, so you can see, yeah, you can see it is basically changing. You can also change the animation setting, maybe the nth frame or per frame per second you can change. It will be faster, little bit faster. And you can also save any of the animations. So this is how basically by clicking this. So this is how basically how animation works in Ovito. So you can also visualize, you can zoom in by scrolling, and you can also do like this, and you can also add several things by basically adding modification. But some of the properties are limited because it is a free version. So you can see if you want to add a modification. So this is the pro version, you cannot use because these are basically for the paid software. So but in the free software you can do several things, so that's okay. So this is basically how animation is done in Ovito. So let me summarize the final points. So for animating the xyz file, so .xyz file, so what you have to do first, you have to write in a specific format for xyz file format. But for animation, for to do animation in JMOL, what you have to do, so you have to give this last space, because otherwise JMOL will not recognize the individual frame. So for JMOL this last space is important, but for Ovito and VMD, so this last space is not important. So that's why maybe this is basically you can write, and then you can just put all of them. So in the MD loop you can just write one by one. So this will write one by one. So if I open a file, maybe that will be easier for you to understand. So maybe this all file. So you can see. So first this atom number is written, then this comment line you can write whatever. If you don't write, just keep it as a blank space, but you have to give the space. Then basically the particle type, let me switch off the line number. So or maybe it is needed, because after 864 it will start another snapshot. So then basically x position, y position and z position. But if you go to after 864, so this is the Ovito and VMD format, so there will be no extra space. So you can see there is no extra space. After immediately basically writing the last particle position, you write again the number of particles and the comment line, and then again the xyz position for the next snapshot. So here it goes up to 866, because the first two lines you have used for the writing this particle number and the comment line. That's why you have total 864 particles, but it goes here, the line number is showing it's 866 because of the two lines in the front. So that's how it works. But here the important point is that in JMOL, if you open, so here this part is same, number of particle and the comment line is same, and then the particle type, and then x, y, z values. But if you go to the 866 line, you see a blank space. This blank space will say JMOL that this is a new snapshot, or new frame is starting, where you will get the position for xyz, new position of xyz. So that's how basically JMOL works. So this is the full procedure of visualizing the molecular dynamics coordinates xyz files, and how to animate the molecular dynamics the xyz file, the trajectory of the particles in molecular dynamics. So this video basically summarizes how to visualize the trajectory of the trajectory of the particles in molecular dynamics, and also how to animate them in 3 different software. You can choose any of your choice, any of the softwares you like. So that's why I described 3 of them, which is Ovito, JMOL and VMD. So you can choose any of them. Each of the software has its own properties. You can go through the softwares, you can go through the manual, and then you can also put your feedback in my Telegram channel, which is Physics Through Computation. You can join to my Telegram channel. There basically lots of discussion on coding is going on. You can join there, and you can post your queries, and you can also post your queries in my Facebook group. So that's basically you can do. Please subscribe to my channel if you are new to my channel, and please share the video among your friends if you like it. And thank you. Please share it and like it. Thank you.